Good morning, student. Let's start today's class. In today's class, we are going to discuss about cathode ray oscilloscope, which is CRO. Okay. So, what is CRO? Okay. CRO is a device or machine used to trace the graph of instantaneous value of rapidly changing quantity like electric current or potential, heartbeat, pressure, etc. You know, the CRO is a device. CRO like this, okay, like this device, and here one digital display are there, and here so many knobs switches are there, okay, and two terminals are getting out, okay. So in that display we get the graphical representation of everything. Everything means the the thing we measure. Let's say we measure the voltage, so we get the graphical representation of that voltage in a in an instantaneous time. Okay, graphical representation means what? In the time axis, the graphical representation means time with voltage or amplitude. Okay, that representation is called graphical representation. So to get that graphical representation, we use that CRO, that cathode ray oscilloscope. Okay, and we also represent the current, AC current, okay, in a graphical representation. Okay, and heartbeat also. You see, you will notice that you will be noticed that the in an hospital, a heart patient have a machine like that which show the heartbeat of that patient. That machine also called CRO. Okay, then this is the block diagram of CRO. Okay, this is the CRT. Okay, cathode ray tube. This is the CRT, cathode ray tube, and this is a vertical amplifier, time based generator, horizontal amplifier, trigger generator, then trigger AC line, exit. So many things are there. Remember this block diagram. Okay, and the block diagram of cathode ray oscilloscope is shown in figure. The various component of cathode ray oscilloscope are the components of cathode ray oscilloscope are: one is cathode ray tube. Okay, this is CRT, this is cathode ray tube. Okay, and two signal amplifier. One is vertical amplifier and one is horizontal amplifier, and one sweep wave form generator. This trigger generator. Okay, and time based generator. Okay, the horizontal and vertical signal are fed to the amplifier. Okay, and then applied to the respective deflection plate. The sweep generator act as a trigger to start at a particular instant in the interval of vertical signal. Okay, external signal. You see, in CRT there is two deflecting plates are there. This plate and this plate. You see this diagram. You can understood this. You see vertical amplifier signal. Okay, vertical amplifier signal going to the vertical deflector. Here you see there is two plates, here two plates, here two plates. This is vertical deflector and this is horizontal deflector. Okay, and the vertical amplifier signal is going to the vertical deflector, and horizontal amplifier signal going to the horizontal deflector. Okay, and this is the fluorescent screen. Okay, the uh, the 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 screen which is I draw that uh, in that this screen, this graphical represented screen is this. Okay, so this is the fluorescent screen, and the electro beam which is generated from this cathode. Okay, this is cathode, this cathode electron beam generated, and that guided by this vertical deflector and horizontal deflector, um, and strike the fluorescent tube and draw a graphical representation, okay, and we get that graphic, we show that graphical representation on that fluorescent tube, okay. So this is the basic concept of the CRO, okay. Now what is the working principle of CRO? The CRO working principle depend on the electron ray movement, okay, because the electrostatic force, okay, the deflector plates have an electrostatic force, and due to that electrostatic force, the beam, the electron beam which is coming from the you see here, this is CRT, okay, this is the screen, and here the cathode is there, okay, and from this cathode one electron beam is generated, and here the vertical plate and horizontal plate are there, okay. So that horizontal plate and vertical plate are this horizontal vertical plate and horizontal plate are um, electrostatically force apply electrostatically force on that beam, okay, and that beam is and that beam um, strike once that electron ray hit a phosphorus phase, that fluorescent screen, okay, that it makes a bright spot on it, okay. A cathode ray oscilloscope applied the electronics energy of electron ray from two vertical ways, okay. The spot on the fluorescent monitor turned due to the effect of these two electrostatic force which are mutually perpendicular, okay, and it moves to make the necessary waveform of the input signal, okay. So this is the basic concept. That means one ray one electronic ray uh, one electronic ray hit the uh, fluorescent uh, fluorescent screen. When that ray hit the fluorescent screen, okay, then one white spot is generated, okay, and by deflecting that electronic ray by using the deflector plate, we can make any or draw any uh, graph, okay. This is the basic principle, okay. Now let's see the working of the CRO, okay. This is the block diagram, okay. So a simplified block diagram of a typical oscilloscope is shown in figure. This is the simplified block diagram, okay. And in the general, the instrument is operated in the following manner, okay. The signal to be displayed, okay, is amplified by the vertical amplifier and applied to the vertical deflection plate, okay, of the CRT. A portion of the signal in the vertical amplifier is applied to the sweep trigger, okay, as a triggering signal, okay. Then sweep trigger then generate a pulse coincide with a selected point in the cycle of the triggering signal, okay. This pulse turn on the sweep generator, okay, initiate the sawtooth waveform, okay. The sawtooth wave is amplified by the horizontal amplifier and applied to the horizontal deflection plate, okay. Usually additional provision signal are made for applying an external triggering signal or utilize a 16 Hz line to triggering. Also, the sweep generator may be bypassed and a external signal applied directly to the horizontal amplifier. So, basically, what happened? Basically, you see in this diagram, you see um, the the signal which we want to measure is applied to the vertical amplifier first of all, okay. And vertical amplifier signal output is vertical amplifier amplify the weak signal, okay, and giving to the vertical plate, okay, deflection plate, okay. Then little bit of vertical amplifier signal is going to the triggering, so generator. Okay, that is uh, that is triggering generator, and that by that triggering generator, the triggering generator trigger the time based generator. Okay, and time based generator generate a sawtooth wave. Okay, sawtooth means like this. Sawtooth wave means this is sawtooth wave. Okay, this is sawtooth wave. So this type of signal the time based generator generate and given to the horizontal amplifier. Okay, and horizontal amplifier amplify that sawtooth wave and apply to the horizontal horizontal deflector. Okay, and by that deflect both the deflector. Okay, uh, giving the deflection force to the beam generated from the cathode in the CRT, cathode ray tube, and we get a waveform. Okay, so this is the basic working of the CRT. Okay, sorry, CRO. Okay, so that's all about your CRO. Okay, thank you.